right, so how do we determine whether or not two things are proportional to each other in a table? So as we've kind of been dealing with our unit rates, we're still going to just look up 2 rows at a time. So if we look at this first table over here, we're actually looking at our cross sections, so what's directly across from each other, and we're determining whether or not through using multiplication our solutions are equal. So if we look at this table on the left, 0 times 6 is 0, 0 times 2 is also 0, so we at least know these first 2 rows are good. That does not mean your entire table is going to be good. We need to go through and figure out the rest of the rows as well. So I'm just going to scoot these down so I know what we're looking at. 2 times 12 is 24. 6 times 4 is also 24. That is good. Scoot them down one more time. 4 times 18 is 72. 12 times 6 is also 72. So we would say yes, this table does have a proportional relationship. All of our cross sections, when multiplied together, they equal each other. We're going to do the same thing at this table over here. So if I have 0 times 10, that is 0. 4 times 2 is 8. So we would say no, this table, we don't even need to go through the rest of the table to determine that it is proportional or not. As soon as 2 rows don't equal each other, we know that's a no. And I do want you guys to notice one thing. If we go back to think of what determines a proportional relationship, if we look at the origin right here, on this table we did start at 0, 0. This one we did not. It was starting at 0, 4, so that also could have clued us in this is not going to be proportional. Because if you notice, this side is going up by 2s, this one's going up by 6s, this is still going up by 2s, this is also going up by 6s. So we are increasing by a solid amount. This is still going to be a straight line on the right side, but we are missing that origin start, which is why that right side is going to be a no. We are not a proportional table.